Computer. Yep. Oh, it's just a thing. All right. And those folks online, make sure you have your cameras on so the face recognition thingy get you. I already marked you here, Will. All right. Okay, so continuing on with our translation from C++ to Java. Last time we probably spent more time than we should have, but it's fine. It's actually pretty interesting, that ROT13 thing. But that idea of chars are actually unsigned integers. So they're instead of signed integers. So when we think about bytes, shorts, ints, longs, specifically if we're your common programmer, 99% of the time we're sitting right there using an int. These are numbers that we're doing math and stuff with. So we probably want to be able to hold positive and negative numbers, that kind of stuff. So that's why those guys are signed. But a char, its only purpose is to be that mapping between holding a number, which computers like, and some chart, which in C++ was the ASCII character chart, and in Java is the Unicode character chart. That allows us to say, okay, well, this number, like 97, maps to the letter A, that kind of thing. So we don't need to hold a negative number for that. They just said, look, we're going to have 65,536 unique characters that we're going to represent. Here's the mapping, but the actual primitive type built into the language knows how to hold a number, but only a unsigned number. Most of you are in the 325 class right now. You'll learn about the difference between how a computer stores a signed number versus an unsigned number. It's something called 2's complement for storing that information using in this case, we have 16 bits. So for a signed number, we're going to be using 15 of the 16 bits to hold the number, and then somehow that extra bit to hold the sign of the number. You're going to look at a couple of different ways that has historically been accomplished, ultimately landing on something called 2's complement, which is the least wasteful of those. Whereas a char, which is unsigned, we just get to use all 16 bits for the number. We don't have to worry about holding a positive or a negative. Go ahead. Yeah, there should be. Yeah, there should be. Just go, if you go to channels, if it's not just showing up in the list, next to channels, say find channel or search channel, something like that. Just type in CSC250. It'll show up there. Yeah, that's the part I was trying to say, whatever that thing was. Okay, so those are our chars. Floats and doubles, these are kind of like integers and longs, so they hold different size floating point numbers. Interestingly enough, when we deal with ints, typically int is the one that we use a majority of the time, and if that just happens to not be big enough, we use a long. But on the floating point number side, we actually almost exclusively use doubles, the larger of the two values in terms of programmers go-to move, that type of thing. You will generally only see floats when you're dealing with some older libraries. You actually probably will rarely see it in Java unless somebody's ported some old graphics library or something like that over. One thing you'll see in the second half of this class when we start looking at Unity using C# as our scripting language, which is effectively Java. It's closer to Java than Java is to C++. So it's we're not talking about a major jump there. But you'll see the use of floats in there pretty often, specifically for doing like these vector things for what's the rotation of an object or something like that. It just happens to be that it's pulling some old C library that just used floats for that. Pretty similar thing with the byte data type. I would say you will almost never see a short used in modern programming, but you will still sometimes see bytes because if we're doing any sort of network programming where things happen to be flowing in 1 byte at a time, that's a convenient, size to deal with the data. Not because there's anything special about the data, that just happens to be the right cup size for dealing with it as it's coming in, rather than having to be wasteful with an int where you're only getting 8 bits into something that can hold 32 bits, something like that. All right, so those are our primitive types. The only difference that we saw last time was a Boolean, which under the hood is stored as an integer, but in Java, they won't let you do math with it. So if I go into here, you could have in C++. So we could say Boolean v is equal to true, and then say system.out.println int version of b, and this will very likely scream at us. Incompatible types, Booleans cannot be converted to ints. Whereas if you were doing this in C++, I think it's a pretty high likelihood, even in modern compilers, it would have let you squeeze the integer version of a Boolean out. Either a 0 or a 1 is what you get from it, because that's how they're ultimately stored. Java just basically makes that decision for us, like we've seen with some other things Java already does, where it says, look, it never makes sense for you to do math with Booleans, so we're not going to let you do it. Make some sense? Okay. So let's start talking about our strings. So these are these primitive types. So things are just built into the language. One of the telltale signs of a primitive type is that it can only hold a value. I'll kind of actually put that in here. So we'll say can only hold a value. No other abilities. That'll make sense here with today's lesson as we kind of show that comparatively. All right. Now, something that we're very commonly used to working with in programming is the idea of a string. All right. To the point that when we think about ourselves as programmers, we pretty much operate as if strings are primitive types. There's something we expect to be part of the language. And if you remember from last semester with C++, we almost made like kind of the rationale for using C++ last semester was that it's not friendly. You get, so that'll make you appreciate these newer language type things. But we still kind of cheated when it came to strings last semester. We used the more modern string library last semester so that our life wasn't just complete hell. Okay, because prior to that, if you go back to early days C and C++, a string was a char pointer. It was a character array, and it didn't have these extra tools that allow us to do stuff with strings that we kind of deem as maybe being necessary as a modern programmer. Okay, good news for us is we don't have to make any special choices in Java. Java provides us a string class, which is every bit as good and then some compared to what we were dealing with in C++. In fact, I will often say that Java is a string-based language. So if you think back to last semester, you maybe would have said, okay, well, strings weren't horrible, but they were still sometimes inconvenient to work with. I tried to do X, Y, and Z with a string, and it was kind of weird, something like that. I might make the argument that with Java, if you can get something into the format of a string, you can basically do anything with it. Strings are incredibly flexible in Java, more so than even other modern languages. And for example, a step backwards, I think I mentioned it at some point in here, Apple's newest language, Swift. My strings are terrible in Swift. It tries to do some things for security purposes with strings, and that makes them inconvenient to use. And then putting things together in strings just becomes inconvenient, and I don't know, just not friendly to use. And if their whole game plan for coming out with Swift is to get the Android developers who are already writing Java code for writing Android applications to come over to the dark side and start writing iPhone applications using Swift, because it was a language that looked closer to Java, which Swift does, I think they kind of failed there. But whatever. So I'd like to think that Java is a string-based language, so strings are very flexible in Java. Okay, so a string is a collection of chars between double quotes. So if we come into our code here, I'll just say string s is equal to hello, something like that. Now, one thing I want you to notice here, you remember back last semester in C++, it was pretty common when we wanted to do something that we needed to put some crap up top here, right? You had to do like an include, IO stream, stuff like that. Remember all those things? Or for strings, you had to include string, and then we were using namespace standard. In Java, it's not that you'll never do that. Every now and then we might use something that is part of another library. But these common things, things like writing stuff out to the screen and things like working with strings that, from a programmer's perspective, are like, you know what, I'm probably going to be doing that stuff pretty often. Why isn't it just included? Why isn't it just already there for me? And why are you making me do this extra crap to get it to work? Java does that for you. Okay, actually what Java did is it just included it in the standard Java library. Which is automatically included, so they didn't even separate them into different libraries. All right, so you don't have to do anything special to start using strings. You can print out a string directly, just like you can in any other language. You can also work with individual characters in a string. So what we want to do is we want to kind of throw out here some of our go-to moves for strings. Now there's lots and lots of methods, and I'll show you in the documentation here in a few minutes for working with strings. Let's call these string common methods. All right, so one of them is a method called length. So this returns the number of characters in a string. Pretty similar to what we had last semester, C++'s. So if I say s dot length here, and this guy is a method, we know it's a method because it has the open and closing parentheses there. This is saying, what is this particular instance of strings length? It gives us our 5. And if I had a different string s2 is equal to elephant, and I said s2.length, I would get an 8. So even though it's the same length method, it's being called on it's returning the information about whoever called it. In this case, s2's length versus s's length. No different than what we dealt with in C++. All right, so we have another function called char_at, which takes an integer as a parameter, and this returns the char that lives at index position in the string. Okay. So for example, if I say system.out.println s2.char at 0, that will give me the very first element in the string. Just like in C++, strings are 0 indexed, so are arrays. So the very first element of any collection in Java is bucket 0 of that collection. So this is at bucket 0, 1, 2, 3, 4, 5, 6, 7. So the very first character in elephant is at index 0, so that's going to be an E. If I say give me the fourth character, it gives you the H. All right, now we can use those two things in conjunction with each other. So maybe a common pattern we might see in Java, really any programming language, is what if I want to have a loop? So for int I is equal to 0, that's the very first position of the very first character in a string. I want to keep going as long as I is less than, let's say, S2's length. And then I'm going to add 1 to I each time. So this is kind of a loop built with the idea in mind that I'm going to take I on a voyage between all the indexes of this string. Now, what I do with that variable is now up to me. I'm not getting the characters yet, but if I want to say, let's just steal this line. If I say I want to print out the char at in S2 I, this is going to print out an E, then an L, then an E, then a P, so on and so forth. And since I'm using println here, it's going to put them on different lines. So this is your common for loop that'll just go through every bucket of a string. So there's your individual characters in that string. All right, kind of a 1-2 punch you'll use pretty often. We saw this last semester, but kind of a reminder type thing. All right, another common method is something called index of. We actually wrote index of last class. We wrote our own version of this. I'll show you. We still have it in the code. I'll show you in a second. We called it something a little different, but we effectively wrote what index of does. So this guy returns the position in the calling string where the char C being whatever character was passed in here, first appears. It returns a -1 if that char is not found. So if I say system.out.println, let's say s.index of and H. In the string S, that's the calling string. That is the string that is calling this method. That's what I mean by calling string. I'm asking S, what is the first index of this character? And it's going to find it at bucket 0, right? Run this, last thing we should see is a 0. There's our 0. If I say an E, it's going to say, oh, I found that for the first time at bucket 1. It's bucket 1. If I say an L, there are actually 2 L's in that string, but this is going to return the position of the first one it ran into, so it will return 2. Okay? But if I give it something that's not in there, like a Z, it's going to give me a -1. -1 is its way of telling us I didn't find it. Now, I'm going to tell you that actually this concept right here is one of our more powerful truths about the index of method. We can use that to solve a lot of interesting problems, and we'll bump into them throughout the semester, but don't discount that idea of, oh, index one just returns -1 when it doesn't find it. Okay, whatever. That's actually, I would say, maybe the more important use of that function. All right, makes sense what index of does? And we wrote that last class with our find index of when we were looking for stuff in the alphabet. We had to go through all the characters in this string. If we found a match for the character we were searching for, we returned the position of that. If we checked everything and didn't find anything, we returned a -1. Make sense? So we pretty much wrote the logic for that guide last time. All right. Now, I would say for all intents and purposes, these are probably your 3 most used string functions. Now, if I go out to here and I say Java string class, that'll bring up the Java documentation here. Scroll through this stuff. So, there's our char at method. This guy takes a integer as a parameter, returns a char, but notice there's all these other functions inside here. I'll actually show you another one here in a second, actually a pretty important one. All right, so we have all these functions. But I've only pointed out a couple, right? All right, so let me go do something here, because this is actually a common thing you run into in some languages, the way they handle string comparison. All right, so just like last semester, we have the same Boolean operators, less than, greater than, yada, 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 double equal sign is equivalent to. Okay, what do we expect the output of this guy to be? Okay, S is equal to hello, S2 is equal to elephant. We expect that to be false. There's our false. What about S compared to S3? What do we expect the output to be? Probably true. All right. And it is true, but it's true for a different reason than you want it to be true for. And let me show you what I mean by that. Almost evidence with what I said in this slide that I said Java is a string-based language. I'm going to throw an extra thing in here, is that Java treats string objects differently than it treats any other object. And what do I mean by that? Generally, in Java, when we create an instance of an object, we have to use the new keyword and the constructor for the object. We dealt with that last semester, kind of in the last last quarter of the semester when we're starting to deal with objects and stuff like that. We had like a player object, and we would have to say like player P equals new player. We created instances of those objects. And if we jump back to the documentation here, I scroll up, we're going to get some skills at reading the documentation, but notice here that we have a constructor summary, and there's a whole bunch of different ways of building strings. So there isn't just one constructor for making a string. We have a way to initialize an empty string that takes no parameters. We can create a string out of a collection of bytes, so on and so forth. We can create a string out of a char array. So I'm going to decide that, you know what, I appreciate it, Java, that you give me these nice shortcuts for building strings, but you know what, I'm going to go ahead and take advantage of how all objects typically work. Any other object in the Java or in the Java programming language that we're going to create an instance of, we'd create it this way. You say, here's the type, here's the variable name, equals, here's the value. And the value in this case is going to be the new keywords are real estate agent, right? Just like in C++, go find me some memory. How much memory? Well, I don't know, however much you need to build me one of these guys. Build me a string for hello. So on the surface, we might say, oh, it's very nice of Java, like we've seen in some other situations, that it gives us this, these conveniences. So I don't have to write all this extra crap because we're probably going to be using strings pretty often, right? Now we saw that S equal S3 was true. Here's S, here's S3, hello equals the hello, we expected a true. Now S equal to S4, what would you expect the result to be? You expect it to be true. Some of you are probably somewhat suspicious of what it's actually going to be right now, right? But you suspect that it should be true. It feels like it should be true. Hello is still equal to hello, right? This guy is going to be false. So there's our false. So the question is why is it false? And that's what's actually important, the underlying thing here. Remind me, what does the new keyword do? Gives me memory, right? So realistically speaking, what's the actual value stored inside of S4 here? A memory address, the base address of a character array type thing, somewhere in memory, right? In Java, we actually don't have a very convenient way of getting at that. Actually, let me try something real quick. Yeah, still won't let me get at it. Yeah, so Java pretty much blocks you out from getting to the actual memory address of a string. Again, it's treating strings pretty much like primitive types. All right, but we're seeing evidence here, since we see the new keyword, we believe that under the hood, somewhere there's a memory address being handed off there. The double equal sign here, that guy, is the primitive equivalence operator. This is where strings get a little bit confusing. So strings are super convenient in Java, but they can also be a little bit misleading, and this is one of our examples. So typically, we would use the double equal sign for comparing any of our primitive types. You can use the double equal sign to compare two integers, two floats, a Boolean to another Boolean, that kind of stuff. Now, Java treats strings in many ways like it's a primitive type, but it is not a primitive type, especially when you consider that over here, I mentioned that primitive types can only hold a value. They have no other abilities. And we've already seen strings do a couple of other things: report their length, allow you to get a character inside the string, tell you where the first place it found something inside the string with index of, and then I showed you the documentation. There was a bunch of other stuff in there it knew how to do, right? All right. So certainly strings can do more than just hold a value. But I'm still saying that in many ways, Java treats strings as if they're primitive types. But when I say S is equal to S3, a human being looks at S and S3 and says, oh, those are the same strings. That should be true. S is equal to S4, a human being says S and S4, those are the same strings. That should be true. But we saw here that that second one was actually false. Why is it? It's because the double equal sign here is actually comparing the memory addresses. This guy compares the underlying memory address of the string, not the contents of the string. Equals. There's no parameters. Actually, I'm sorry. It does take a parameter. Returns true if the calling string has the same contents, case sensitive, as S. So I'll show you that here. Okay. So if instead of saying S is equal to S4 using the double equal signs, which compares their addresses, their pointers, I'm going to say S dot equals S4. This will be true because the contents of S is, including case sensitivity, the equivalent contents of S4. There's your true. So in Java, the string class has a built-in function, a built-in method that allows you to compare one string to another string if you're trying to say, do these guys contain the same collection of chars? All right, it's right there for you. So you'll never run into this problem if you just always use the dot equals method when you're working with strings. All right, but what's somewhat misleading here is other programming languages, including many modern languages, have gone ahead and said, you know what, people are using strings pretty often. I would say an extremely high percentage of time, not significantly less than 100% of the time. When you compare two strings to each other, what you're really asking is, do they contain the same characters? That's what you're actually asking. Very, very, very rarely are you actually meaning to ask, are these guys stored in the same place in memory? And I'll show you a picture of that here in a second, but go ahead. Yes, that's the picture I'm about to draw. They are different variables, but they contain the same value. They contain the same pointer to a place in memory. And that'll make sense when I draw the picture. Go back there, please. No, I just slapped them in there in that order. You mean, can I like say S3 is equal to Woot? Well, yeah, but now S3 holds a different, variables allow us to change the value of them. This is nothing special to strings, just a variable not being a constant. You could say, hey, you're equal to a 3 right now. Now you're equal to this, you're equal to this. You just change it all over the place. But yeah, now S3 holds a different value. In this case, it holds a memory address, which points to Woot. There's a question over here. Go ahead. Yeah. And I think that'll make sense when I draw the picture. So let's go and draw the picture. All right. So let's say Java. I'm going to call it literal memory space. So when I say something like string S is equal to hello, it views this hello piece over here. It says, oh, that's the literal string value hello, which is no different than me saying, let's just take something away from strings. Int a is equal to 5. That is the literal value 5. Okay. Literals are just hard-coded values of types that are built into the language. All right. Now, this ultimately means, so I'm going to say 0x1. I'm just going to make up memory addressy things. So at that bucket, let's say we have hello. And then at another position, we're no good. Don't worry about the reason behind that. There's going to be a 5 there. Okay, so this int a actually, now int is a primitive type, so it is holding the actual value 5, but that value 5 has to live somewhere, and the language will preload it into some place inside of Java's literal space. Java literal memory space. So now if I come in here and I say string s2 is equal to hello, again, and actually let me, before I do that, I'll say int b is equal to 5. Now, in your brain, when I say the number 5, you already know what a 5 is, right? You know, you know numbers, and 5 is one of the numbers that you know, and so you've stored that one time inside your brain. Okay. And if somebody says, hey, I have 5 fingers, and somebody else says, hey, I have 5 toes, you didn't have to store that 5 2 separate times. You're associating that same number 5 to the number of fingers and to the number of toes, right? So Java is going to say, oh, you want to create another variable named b. Okay, I'm going to go create some memory for that guy. But you want it to be equal to 5? Fine, I'm going to go check my literal space. I already have a literal called 5. A literal whose value is 5. So I'm actually going to put this variable b in its own memory space because that variable lives someplace else, but its value is going to be associated with this same 5. All right. But primitive types only hold the values. They hold a copy of the value found at that memory location. Object types like strings, they actually hold memory addresses. So when I try to create string s2, and I say, oh, you're going to be equal to the string literal hello. Well, the first time we created the string literal hello up here, Java said, oh, I don't already have the string literal hello stored. So I'm going to go ahead and create a place for memory for that guy right there. So in actuality, this guy holds that value, which points to the primitive that lives there. Now, the second string we create, string s2 equal hello, Java's going to say, oh, you've given me another string literal. Let me go check to see if I already have stored that guy. It'd be wasteful to store the same literal more than once, right? So Java's going to go through, look at its literal space, and it's going to say, oh, I already have that same literal stored. So rather than store it a second time, I'll go ahead and just say, you can find your value at the same memory location as anybody else who's used that same literal previously, okay, because I'm only going to store it once. So now when we ask a question, like S is equal to S2, it's going to be true because this memory address is equivalent to this memory address. But if I say string S3 is equal to a new string hello, I'm bypassing that automatic literal lookup. I'm specifically saying to Java, I want new memory. You will give me new memory. So Java's no longer going to say, okay, but I already got this stored somewhere, buddy. It's going to say, oh, you want new memory? No problem. We'll go get you some new memory. So this guy holds that memory address, let's say. So if we were to say S is equal to S3, this is false because 0x123h is not equal to 0x127h. Those memory addresses are different values. Object types hold memory addresses, just like they did in C++. So when you use the double equal sign to compare two memory addresses, those are the primitive types stored inside of objects, you're asking, does this guy and this guy live at the same place in memory? We're not asking about the contents. Make some sense? What's going on there? Very, very, very confusing even for modern programmers. Because I would say that a majority of new languages that come out right now have overloaded the double equal sign to automatically function for strings. Where this guy right here, I'm sorry, not that one, this one. No, this guy. That guy right here, which we are seeing as a false, right? Because the memory address for this is different than the memory address for this. In many other languages, Python included, this would be true. Because in those languages, the double equal sign is behaving in the way that a human being probably meant. Which you could say that kind of makes sense, right? If you're a computer programmer, you'd be hard pressed to come up with an actual example where you really, really, really care if two strings live in the same place in memory. Memory is not all that important to us in terms of what human beings are typically problem solving with, right? Like we can appreciate, okay, under the hood, the computer's got to store this crap somewhere. So it's going to put stuff at this memory address, whatever. But I don't really care. As long as it's figured out where to store it, I care about the values, right? So more than likely, if we're saying double equal sign and we're working with strings, we're saying, do these guys hold the same stuff? So a modern language, it would be reasonable for them to say, okay, let's go ahead and let the double equal sign behave a little differently for string types, because that's what the programmer wants, and why should we make them write out dot equals or some other function like that in order to accomplish the same thing? Make sense? Okay. Now, it's easy enough for us as programmers to, just say, okay, well, so Java has that caveat, right? But the fact that languages tend to almost do the coin flip on whether or not they're going to support this, although I would say probably 80+% of modern languages probably let the double equal sign compare the contents. So Java would really be the outlier here. It can be a little frustrating for programmers if you just become so accustomed to using the double equal sign for comparing strings, where now all of a sudden, sometimes it gives you the result that you were expecting, but it gave you the result for the wrong reason. If you happen to preload it with literals, where you're saying, oh, S equal to S3, yes, that's true, obviously, but it gave you the true value for the wrong reason, not the reason you meant. That makes some sense? Okay. So what I would say is, with strings, as a Java developer, best thing to do is just to always use the dot equals method for comparing strings. All right, any other questions about that double equal sign thingy? All right, so we'll put equals string S. I know I have it on another thing. here's another interesting thing. Compare to string S. This guy returns a 0 if the strings contain the same values, the same contents. Case sensitive. Less than 0 if the calling string comes before S. I'm going to say alphabetically because that's going to make the most sense to us. It's actually something called lexigraphically, which takes into account like the Unicode values, takes into account like punctuation and things like that. But realistically, we're going to say alphabetically. And greater than 0 if the calling string should come after S alphabetically. Make some sense? So if you happen to want to compare strings in terms of which one comes first alphabetically, you could use the compare to method to give you that. You could also always use the compare to method instead of equals and just check to see if it returned a 0. If it gives you a 0 as a result, they were the same. If it gives you anything other than a 0, they were not the same. Make some sense? All right, so we'll do another simple assignment just to get you working with these strings and stuff like that. So write the code necessary to, and at this point, you don't have, you can put it in a function if you want, that would probably be preferred, but I'm going to talk a lot more about functions, static versus non-static functions next time. So this is more, I just want you to practice with strings. So if you just want to put all this in main, that's fine. So write the code necessary to display the contents of a string in reverse, 1 character per line. Shouldn't take you very long. Should be pretty easy to do, but we'll get you used to using the Java syntax for stuff and the string functions. Make sense? So make sure you submit a link to the code and the self-assessment thing. That thing that's on the left-hand side of Blackboard. Less important for things like this, but just get into the habit of always submitting it because it's going to be much more important when we get to harder programs very soon where they are going to be challenging. Questions, comments, concerns, bribes. This is due Monday. All right, I'll see everybody on Monday.